Hello, my name's Peter Glynne-Jones, and I'm going to give you a brief introduction to the Mechatronics theme here at Southampton University. Mechatronics is really the meeting place of mechanical engineering, electronics, and computing and control. And the magic really happens when you bring these three areas together. And this list of examples here gives you an idea of some of the many areas in which the close integration of those different factors is really important. During your course, there are specific modules which I'm going to highlight here, which contribute to your mechatronics expertise. In the first year, particularly, there's the electrical and electronic systems and the design and computing modules. As you move on into the second year, there's especially the electronics, drives and control module. In the first 2 years, you'll have been studying alongside engineers from all the other different specializations. But in the third year, your theme dictates your core modules and also gives you, in the third year there are core modules associated with mechatronics, particularly the automotive mechatronics and the control and instrumentation modules. And then in the fourth year, there's a chance to choose some optional modules in addition to these two on the left, which are the core ones, the advanced electrical systems and the advanced sensors and condition monitoring. These are just a few examples of some of the options you might take. There are a number of others you could choose from. By way of a case study, I'm going to look at quadcopters for a moment. It's only been in recent years that quadcopters have really been a possibility. And it's because of the advent of miniaturized sensors and microcontrollers that it's become possible for these tiny, often drones, to fly in a stable fashion. If you look at the components that are essential to making a quadcopter functional, I've identified these three main blocks. To start with, you have the sensors. And here we have a MEMS, which stands for Micro Electromechanical System, a MEMS accelerometer. And this is required to detect the orientation and acceleration of the quadcopter to enable the very fast feedback and control that's needed to maintain stability. And look at the scale of this. Someone's engineered this whole thing to be less than about 1 millimeter across. We've got springs, we've got electrostatic actuators, we've got the vibrating gyroscopic ring arrangement in the center. The engineering in this is astonishing. The output from the sensors feeds into a microcontroller. And I don't think people really appreciate the rate at which modern microcontrollers can process instructions. So at 100 megahertz, for example, a microcontroller will be executing an instruction every 10 nanoseconds. And it's this rate that makes possible the very quick taking on board the output from the sensors, using complex signal processing and control algorithms to then decide what to do, what output to make to the actuators and motors. We study motors as part of mechatronics, and here we have one of the rotors of the quadcopter. Within the department, we have a number of facilities that will be particularly of support to you when you do your third-year individual project and fourth-year group design projects, which often have a mechatronic component to them. We've got a dedicated mechatronics testing lab. We have the design and fabrication facilities of the EDMC and others. We're particularly lucky to have a thick film sensor fabrication facility. You can see the picture here of a thick film sensor with some integrated components. And there are also dedicated electronic workstations to enable you to put your projects together. Finally, a brief look at what careers might be open to you once you've completed your degree. And And the list is actually very, very large. For an engineer that really has the skills to integrate mechanical systems with computing and control, those engineers are really going to be in demand in today's job market. So just take these items here as a few examples. Thank you very much.